another derivative, and our trusty formula will help us again. By the way, if you're dreading the thought of doing this limit over and over for the next couple of months, you're not going to, because this limit technique is old school. This is how derivatives were done 400 years ago. And there is a new way of calculating derivatives, which we're going to show you rather soon, which is very slick and doesn't have a limit in it and gets these done a lot quicker. We are showing you this way because the idea of it being computed like a slope is very important, and it'll help you understand things that come later. And that's why we start doing this rise over run technique. But if you're getting tired of doing these, take heart, it's not going to be around for much longer. The modern methods are very efficient and very fast, and they'll knock these things down in just a couple of lines. So you have that to look forward to. But for now, they said using first principles, so this means do it like they did in 1600. So away we go. Our f of x is given to us. It is 1 over x squared. F of x plus h would be, everywhere there used to be an x, put x plus h instead. So there we go. That's our f of x plus h. So let's set this up and see what we can do with it. We get 1 over x plus h all squared minus 1 over x squared, and all that is over h. No roots, no factoring happening, so common denominator, I suppose. Let's get these fractions combined and hope something good happens. This first fraction needs an x squared, top and bottom. There we go. This second fraction needs x plus h squared. There we go. La, 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 squared. All right, so if we expand all that, let's see, or not expand all of it, but if we combine these two fractions, let's see what we get. Limit as h goes to 0, x squared from the first fraction. Then we get minus, oh, I get to expand this, don't I? Okay, x plus h squared is x squared, and I'm putting on the minuses as I go. Then we get 2xh and h squared. All of that is over x squared x plus h squared. And all that is a numerator over h. Okay, so f of x plus h, f of x, common denominator, and now I'm doing, when I expand this, you get x squared plus 2xh plus h squared, and then I applied this minus to every one of those terms, so there they are. We get a cancellation, which is nice. X squared minus x squared drops out, and that leaves us with minus 2xh minus h squared all over our giant denominator. And then I'm going to do my times 1 over h thing because I need to conserve space and I don't want my fractions to get too horrible. And, oops, sorry, all this is in the limiting case as h goes to 0. So, this 1 over h, I can divide both of these terms by h to take care of that. So I'll divide by h there, and in this term the h will just drop out. It's gone. In this term, h squared divided by h will leave just a single h. So that gets us to limit as h goes to 0 minus 2x minus h all over x squared x plus h squared. Okay, and I think we're finally ready to go. If h goes to 0 now, this was the part that would have caused the trouble in the division by 0. It is now gone, so if I put h going to 0, I'm going to get minus 2x minus 0, which I'm not going to write, over x squared times x plus 0 squared. This cleans up to minus 2x over x to the 4th. And if we divide both the top and bottom of that by x, we get minus 2 over x cubed. That is our derivative. So you can write either f prime of x equals this, or dy dx equals this. That's the equation of your line. And now, if x is 2, we can put that in and we find that the slope is minus 1/4. dy dx, I'm using Leibniz notation because I like it and I want you to like it too. Minus 2 over 2 cubed is minus 1/4. That's our slope. Last little thing, and I forgot this in the previous example, they want us to write the equation of the tangent line, which we practiced a lot in pre-calculus. We need to create the equation of a line which has a slope of minus 1/4 and passes through the point 2 1/4. So, okay, that's not too bad. Our line is y equals minus 1/4 x plus a b that I don't know yet. That's just taking this slope and feeding it in. And now we want that line to pass through 2 1/4, meaning when x is 2, y is 1/4. We can put those numbers in and we get y equals minus 1/4 x plus an unknown b. Let's see. I'm going to go to decimal form just because right now that feels like it's going to be easier. 0.5 plus b. My head is not in the fractions right now. If you do this in fractions, no problem, it's going to work out. I get 0.75, so b is 0.75 or 3/4. I just didn't feel like dealing with fractions for a second there, but this still works. I add a 0.5 to both sides, I get 0.75 equals b. 0.75 is the same as 3/4, so now we're good. And our tangent line, sorry for the cramped spacing here, is minus 1/4 x plus 3/4, the end.